This is Algebra 1, Lesson 5-3. Today's date is January 10th. I'm out today because Riley is sick. This is a really big lesson today, and I really wish I was there to teach it, but sadly, yeah, he's sick. So the first half of today's lesson, the whole front side of the notes are super, super important. You'll be using slope for the next few years of your mathematical career, so you really need to have this down, especially for the rest of the unit, because everything is based off of this. Let's get started. So slope. What do I mean when I talk about slope? And I think to help us out, I have this demonstration here. So I have a line, a graphed line. I can change the slope of the line. I can make it not very steep, or I can make it really steep, or I can make it negative, not so steep, negative, really, really steep. The steepness of this line is really the slope. So the slope is the steepness of the line, or of a line. It doesn't have to be the line, of the line. So how steep is the line? That's really what I'm after. All right, and then here's your formula for slope. And this is the formula that, again, you just have to have this formula down for the rest of your mathematical careers. It's delta y over delta x. That's it. And what do I mean by delta? What is this triangle thing? I say that this triangle thing right here is called delta. And I forget if I've used that before, but delta just really means change. So I'm going to do this in a different color. All I mean is change. It's a mathematical symbol that just says it's a change in y and the change in x. How much did you change in the up and down direction? So y is the up and down direction. And how much did you change in the left and right direction? Because y is going up and down, x is running left and right. And that's all there is for slope. Try to memorize that formula, delta y over delta x. Always go up and down first, then left and right. All right, so we're using this definition of slope to find what the slope is from a graph. And notice that the slope right here is a fraction of y over x, so we should be looking for a fraction. All right, what is the slope of the lines below? These lines, the way to find slope is by finding an intersection mark with an actual number. You can see that there's no number intersection here. While there is an intersection right here at with 1, this line right here, there's no intersection with a number in this direction right here. There's no y number. So let's find a good number. Ooh, look, this right here is a perfect intersection point because we have an intersection with -2 and an intersection with 0 on the x-axis. Let's see if we can find another intersection. Nothing down there. Is there an intersection? Ah, right here. There's another intersection. Once you find your two intersections, then we're ready to go to the next step. I need to ask myself, how much did I change in the up and down direction? What is my change in my y? My change in my y, well, I can change, let me do yellow. I've gone, let's assume that we're just starting from this point on the left bottom and we're going to the top right. It doesn't matter either way, just choose one point and stick to it. So I'm going to say I'm going from this point to this point, so that means I've gone up +3. All right, well then what is my change in my x direction? My change in my x direction, I'm going to do that in a different color. I've gone right 2 +2. So my change of y, this is my, I'll notate this too. This is my change in y, and this was my change, got some lag there, this is my change in x. So I just make this into a fraction. The answer for this one is 3 over 2. 3 over 2. That's the answer. Box it. The slope of this line is 3 over 2. It went up 3 and it went right 2. If you did it the other direction, for example, if you decided to go from this point to this point, then I would have gotten -3, I would have gone down 3, and I would have gone left 2. I would have gotten -3 over -2, but negative divided by negative is a positive. You'll still get 3/2, so you get 3/2 either way. It doesn't matter which point you choose. All right, let's try the next one. And I would like you to pause the video now and try this one out on your own to see if you can try it, or see if you can solve it. All right, so you've unpaused the video. Again, I'm looking for intersections that have somewhere on these little intersections. They're technically called lattice points, but somewhere where there's an actual number for the x and y. So I see an intersection at this point, and this point, and this point. There's quite a few of them that I can use. There's one up there as well. I'm just going to use these two right here. And again, it doesn't matter. Any 2 points will work. You just need 2 points to make a line. And that's kind of the definition of a line. All right, so I need to ask myself, what is the change in y? I'm just going to randomly say I'm going to go from this point to this point, from 1 to 2. So how much in the y direction did I change? Well, I went down 2. I had to go from here down 2. Down is a negative direction because you can see negatives are down. So I went down 2, so I have a minus 2. Okay, and then how much did I move to the left and the right? Well, I went this direction. I went right 1, and that's a positive distance of 1. So again, I just make my fraction. My slope is equal to negative 2 over positive 1, and that is the answer. I guess I could simplify this a little bit further and say, okay, well, negative 2 divided by 1 is just negative 2. Both of these are fine. You can say this, oops, you can say negative 2 over 1, that's totally fine, or you can say negative 2. Both of those are correct. So that is the slope of this line. And a good way to tell whether or not you have a positive slope or a negative slope is think about dropping a ball on the left-hand side of the graph. If I drop a ball right here, will it roll uphill or will it roll downhill? If it's rolling uphill, then it's positive. If I drop a ball right here on the left-hand side of the graph, it'll roll downhill because it's a negative slope. If I drop a ball here, it'll have to go uphill. It's a positive slope. So a little hint there. Let's find the slope using 2 points. So this is basically the same thing without a graph. So now it's telling us a point on the graph, another point on the graph, and telling us find the slope. And we're still using the same definition that we use up here, delta y over delta x. Change in the up and down, the change in the left and right. All right, so which of these is x, which of them is y? Well, this is x, this is y, this is x, this is y. So we need to find the change in these numbers first, 3 and 8, because that's our delta y, and then we're going to find the change in 1 and 3, our x's. So I'm first finding the change between 8 and 3. So what is the change? How far did I move to get from 3 to 8? Well, I moved 5. And make sure that you're always doing 1 point minus the other. I'm just going to say that this is point 1, this is point 2. I'm going to do 2 minus 1. You could have done it 1 minus 2. It doesn't matter the order that you do as long as you keep that order the same. There is a formula for this that I don't want you to memorize, but here is the formula just in case you do want it. So you don't need this. Don't need it. But if you want it because you really like formulas, here it is. It's going to be y2 minus y1 all over x2 minus x1. You don't need that formula, but it comes from this definition of delta y over delta x. You just choose 0.2 and subtract 0.1. So my y, so I'm going to do 8 minus 3. So this is equal to 8 minus 3. And then my x and my x. Again, I have to choose the same point. If I chose 8 as my first point, I have to choose 3 as my first point down here. I have to choose the same point. So it's going to be 3 minus 1. Okay, and then I just have to simplify this. 8 minus 3 is 5. 3 minus 1 is 2. And there's my answer. My slope is 5/2. All right, so everything that I've talked about here is super important for the rest of the year. This backside is important, but not as much as just finding the slope of a line given 2 points on a graph or just in a sentence, I guess. Make sure you really have that front page down. All right, let's talk about horizontal and vertical lines. So horizontal versus vertical, let's look at a graph first. You don't need a ruler to do this, but it is nice if you have a ruler, I guess, to make it nice for your notes. Horizontal line just means you have lines that are just going left and right. So that's a horizontal line. Here's another horizontal line. Here's another horizontal line. Those are all horizontal. And the way that I remember horizontal is the horizon. You can look off into the horizon and then you can see a sunset, for example. So I'm going to just do a little picture. There's the sun. It's setting on the horizon. I know that horizontal means horizon, they go this direction. However, vertical lines go this direction. These are all vertical lines. there's no horizon, there's no sunset unless you're in some weird world where you have to tilt your head to the right or the left. All right, so that's the graph of horizontal versus vertical. What does the equation look like? This is just something that you're going to have to memorize. And it does make sense, but I can't explain it in depth in this short video, and I apologize for that. But the equation of a horizontal is y equals some number. So y equals 5. Oop, that was a bad 5. Y equals 5. Y equals 3. Y equals -7. Wherever it passes through, so say that this point right here is -1, 2, that point is -2, that means this equation right here is y equals -2. Let's count down here at -2, -3, -4. This point right here is -4, which means the equation is y equals -4. So now we can match an equation with a graph. Okay, well, but vertical means instead of using a y, I'm going to choose the other letter, which is x. So this is going to be x equals any number you want as long as it's passing through that number is x equals 1, x equals 0, x equals -7. As long as it's x equals, it's going to be a vertical line. Well, let's count these. So if I go -1, -2, -3, this point right here is -3, 0, which means the equation here is x equals -3. If I count in this direction, 1, 2, that means x equals 2 for this line. Now we can match the equation to our graph for vertical lines. And there's one last thing I want to talk about for horizontal and vertical lines. It's the slope of that line. Okay, well, the slope of this line, you can actually calculate it. You can say, how much up and down did you go? Well, I didn't go up and down, so my delta y, I didn't move up and down, so it's 0. My change in x, I could be any number. It could be 5, it could be 10, it could be 7, it could be 1. Anything, 0 divided by any number is just 0, and that's the key thing to remember. The slope of a horizontal line is always, always, always 0. Let's take a look at this one. Vertical lines. Well, again, you just use the slope formula, delta y over delta x. We need to have that slope formula memorized. Okay, well, how far did I move up and down? I can choose any number. I went up 3, I went up 5. It doesn't matter. Again, this is just a number, so let's just choose 7. And then how far left and right do we move? We don't move left and right. We have no movement in the x direction. And if you write this down, it's actually a math swear word. We can't divide by 0. That's bad. This is undefined. And if you are in calculus class, we would talk about how the slope might be considered infinity. But for now, let's just consider this undefined. And this makes sense too. So if we come back and look at our graph, so if I come back here and I say I have a slope of 0, it's a flat line. And if I get really, really high, a big number, let's change this 3 to like 100 and drag this all the way to the right. The closer I get to a really, really big number, it's almost a horizontal, or it's almost a vertical line, but it doesn't quite become a vertical line. If I zoom really far into this point, you can see that it's still not quite hitting this point 0,6. All right, so we're almost done with the notes. I know that this was a long pair of notes. So example 1, what is the equation of this line? Okay, so the first question I'm going to ask myself, is this a horizontal or is this a vertical line? And then I have to come back up here in my notes. Okay, it's a vertical line because I can't draw the sunset. The sunset is the horizon. It's not a horizon, so it's vertical. So I know that this is a vertical line. So the equation, is it going to have an x or a y? Well, the equation for a vertical line has an x in it. So it's going to say x equals, okay, and now I need to say, well, what is the point that it goes through? It goes through all of these -3s. So x is equal to -3. Final answer, box it. Whoa. There we go. Let's do example 2. What is the equation of the horizontal line? It already tells us that we're in the horizontal. We don't have to figure that out. It's a horizontal line, so that means we are on the left side of our notes. It's a horizontal line, and it passes through those 2 points, 4 and -7. Well, notice that 4 is the x-coordinate, 7 is the y-coordinate. Which one do we care about for horizontal lines? Horizontal lines is where y equals, where y equals, where y equals. So we care about the y-coordinate. The y-coordinate here was -7, so the equation is going to be y equals -7. You just set it equal to whatever is the important letter. It's y in this case. If it was a horizontal line, we would look at whatever the x was. And that's our final answer. Box it. All right. There are 3 homework assignments for Khan Academy. Make sure that you spend time to really understand the slope questions. There's 2 homework assignments. One of them is like this. One of them is like this for slope. And then the third assignment is talking about horizontal and vertical lines. Make sure that you're updating your uni guide, and I'll see you guys on Friday.